Steve, on the floor of AUVSI 2014, I dare anybody to walk these halls, see what you've got on display, and not just go nuts. Tell me what you're doing and what's the future of this program.
So we're here, Yamaha Motor USA, under the Precision Agriculture logo. It's the first time we've really displayed here at the show, showing our RMAX and our brand new FAZER remotely piloted helicopters. We are precision agriculture crop sprayers, basically. So these are remotely piloted, they're not autonomous. They basically use an industrial level transmitter, 72 megahertz. We've been operating these in Japan since 1991. The average farm size in Japan is about 5 acres. So we're talking relatively small size here. We've been able to go into Japan and treat 2.4 million acres annually. That's about 40% of the rice crops in Japan. So here in the US, what we're looking at are high value crops. And specifically right now, we've been doing a lot of research in Napa, looking at the grape industry and the vineyards there. What we found is that we fly what I like to call low and slow. We fly 3 meters above the crop at a speed at about 12 miles per hour. Their current method of spraying there is by a ground rig, moving at about 2 to 3 miles per hour. So basically what takes them about an hour to do 1 acre, we're able to do as high as 16 acres in an hour, depending on the number of passes that are required to get the desired coverage. And I've got to be honest with you, it's a lot of fun to operate. When you have something fun that's efficient to do, it seems to be making a lot of sense in Napa right now. So we're going to expand looking at further high value crops. And in those parcel of lands, it makes sense for something that has the payload capacity of the RMAX, which is basically 60 pounds. The RMAX and the FAZER are very precise applicators, okay, and so that's great. That is what we do, it's what we know. But we also know sensing, monitoring, power line inspection, forest fire observation. There are a lot of other applications that we can look at to expand the use of a platform like this.
Now, you had mentioned RMAX was the unit that you brought into the market, but FAZER was something that was in the process of becoming the future. How does FAZER change?
Okay, so if you look dimensionally between the FAZER and RMAX, they're basically the same size. They're basically 9-foot airframes. But what we've done is modernize the power plant. So the RMAX is a horizontally opposed 2-stroke 246 cc carbureted power plant. The FAZER is a 4-stroke 390 cc fuel-injected power plant. It offers 24% more horsepower, and through lighter frame design and use of lighter metals like titanium in the exhaust system, we're able to get 50% more payload capacity out of it. So it's going to be the future. Now, both will be continued to be produced and operating side by side for the near term. But eventually, production will shift to the FAZER, and that'll be the future as we go forward.
How do you acclimate an operator? Joe Blow's got a couple of farms and he wants to keep the blight off them, so forth and so on. Is this something he does himself?
The fit that makes the most sense is that we look at existing ag operators who are providing the service already. And this would be an expansion to their service. The one thing that we like to say about the RMAX is that you've got several advantages to ground rigs in that you're not getting soil compaction, no crop damage, and since it's unmanned, you're getting no applicator exposure to chemicals. So there's a number of advantages to using unmanned technology like this.
What's something like this cost to run? What does it cost to obtain? And more important, overall, what's the service life of a vehicle like this?
What makes most sense and what we've done in other markets is that these aren't sold outright. They would be offered through a fully maintained lease. And within that lease, you would have training wrapped up, you would have all the maintenance of the aircraft wrapped up into that lease agreement. Now, as far as the service life of a product like this, you're looking at about 1,000-hour service life on the airframe and the engine itself. There's 100-hour service checks, and there's more of a major service at about 500 hours. And what we found is about the average annual operating hours of a machine like this is about 100 hours. So you're looking at about a 10-year service life on an airframe like this, and if it were handled through the lease agreement, it would just be replaced with the new unit at that time.
Are you looking at additional capabilities down the line to include autonomous flight and things of that nature? Is that something you're entertaining?
I think that is the future, but we are so experienced at remotely piloted line-of-sight operation. That's how we operate in Japan, that's how we operate in every other area of the world. There are autonomous versions of these aircraft, but they've been used more for monitoring. For example, at the Fukushima nuclear plant, an RMAX is used, an autonomous version for radiation monitoring there. So those capabilities exist. But to enter the precision agriculture market, we're going to do it remotely piloted, line of sight, with a move towards autonomy in the future.
Aero-TV is brought to you by...
Finally, the extraordinary story of the world-changing X-Prize space competition is being told and illustrated with hundreds of insider photos in Jim Campbell's colorful new book, Beyond the Blue. Journey with Jim as he flies formation with spaceships, plays in zero gravity, prepares rocket racers, and documents the amazing first decade of the personal space race. Available this summer. Get your advance order in now by checking out www.kindredspirit.com.